Hello students, welcome to today's session. In this session, let us discuss about Newton's laws of motion. So this Newton's laws of motion, they are the heart and soul of the physics. Why these laws are called heart and soul of the physics? After learning this, all the concept you will get to know. Okay, actually Newton has given 3 laws to describe the motion of a body. Okay, who causes motion? Suppose a body of mass m, it has to attain a certain velocity, then we have to apply some external force, right? So when we apply an external force F on a particular body, it attains certain velocity and it starts moving. So to move or to motion of any particular body, we require a force. Okay, so this total Newton's laws of motion depends upon the topic force only. Force causes to move a body. Okay, force is the cause to move a particular body. So as Newton has given 3 laws to describe the motion of a body, as we know that we have 3 laws. Newton's first law, second one is Newton's second law, and third one is third law of motion. First law of motion, second law of motion, and third law of motion. Okay, now coming to Newton's first law of motion. Newton's first law of motion, NLM1, Newton's first law of motion. A body at rest remains at rest. A body at rest remains at rest, and a body in motion will continue in motion in a straight line with a uniform speed unless it is compelled by an external force to change its state of rest or of uniform motion. Suppose students, here we have a body of mass m. Until and unless if you apply an external force, the body remains at rest only. The body remains at rest only. It will not change its position. So that is the first point. A body at rest remains at rest only. Second one. For example, a body is there which is traveling with a uniform speed in a straight line, will continue its motion until and apply if you apply some external force on it. So that is our Newton's first law of motion. New force apply చేయనంత వరకు ఆ బాడీ పైన ఏ ఫోర్స్ అప్లై చేయకపోతే రెస్ట్ లో ఉండేది రెస్ట్ లోనే ఉంటది. సపోజ్ ఇఫ్ ఇట్ ఇస్ ట్రావెలింగ్ ఇన్ యూనిఫామ్ మోషన్ ఇన్ ఎ స్ట్రైట్ లైన్, దెన్ ఇట్ రిమైన్స్ ఇన్ స్ట్రైట్ లైన్ only. So that is our first law of motion. Newton's first law of motion, we can also call it as a law of inertia. Newton's first law of motion, we can also call it as law of inertia. Why we call it as law of inertia? The tendency of a body remains at rest if it is remains at rest of it moving to continue in moving in a straight line is called as inertia. So as any body, if it consider any body, this is the law of inertia, means that is the tendency of a body remains at rest only. Or else if you continue in moving, it will be moving continuous straight line. So that scenario is called as what? Law of inertia. So Newton's first law of motion is also called as law of inertia. Suppose a body, a toy is there, a toy car is there. If you apply a force, you need to apply a certain force. If you apply a small force, it attains certain velocity. Suppose if you have a real car, until and unless if you apply force, it will not move, because we need some external force, then only it will start moving. So in order to move a particular body, we need a force. Force can cause the motion of a body. So Newton's first law of motion is a body is at rest, will remain at rest, and a body in motion will continue in motion in a straight line with uniform speed unless it is compelled by an external force to change its state of rest or uniform motion. So this is our Newton's first law of motion. Now coming to Newton's second law of motion. Before understanding Newton's second law of motion, first of all we should know the term momentum. Students, what do you mean by momentum? Momentum is nothing but it is a product of mass and velocity. Suppose you you take one cricket ball and one tennis ball. As we know that the weight of cricket ball is heavier than the tennis ball. You start leaving both at the same time. Then obviously cricket ball reaches the ground faster than tennis ball. So because it depends upon mass of the body. The first criteria is mass. First criteria is mass. Second one, what you do, you consider two cricket balls of same weight. Two cricket balls of both are of same weight. Now what you do, you start throw the balls at the same time. Okay, then what will happen? If they both are of same height, see the force required to stop a moving body is directly proportional to its mass. The momentum of a body is defined as product of its mass and velocity. It depends upon what and what? Mass and velocity. Okay, the force required to stop a body moving with a higher velocity is more. Okay, we have taken two balls of same weight. Okay, one ball is traveling with a higher more velocity, and then the other one. Then in this first case, the ball which is moving with more velocity, it requires more force to stop the ball. So students, the word product of momentum is represented by letter P, is nothing but which is the product of mass and velocity. So the formula for P is what? P equal to m into V, that is mv. Here P is the momentum of a body, m is the mass of the body, and v is the velocity of the body. Okay, momentum in the sense it is the product of mass and velocity. Okay, once if you understand momentum, then we can go with the Newton's second law of motion, NLM second. So the rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction in which the force acts. Suppose we have a body of mass m whose initial velocity is u. Then what is the momentum of the body? mu. Right? Now what we have done, we have applied certain force F on the body, then it attains certain velocity, we call it as v, in time t. So what is the velocity, what is the momentum of second body? That is mv. So the rate of change of momentum, I mean F is directly proportional to change in momentum means mv minus mu by in time t. So F is directly proportional to, if you take m as common, you will get v minus u by t. Students, we know that acceleration is nothing but change in velocity by time taken. So in the place of v minus u by t, I can write as what? Nothing but acceleration. So F is directly proportional to m into e, mu. So if at all, what is Newton's second law of motion? We need to say that F equal to mu. What is F? Force. Force is directly proportional to the mass. See, the rate of change of momentum of a body is directly proportional to the applied force, and that force act in which direction the force acted. That direction it happens. So force is nothing but what? Force is directly proportional to the mass and acceleration. F equal to ma. F equal to ma is called as Newton's second law of motion. So here First one is momentum, nothing but product of mass and velocity. Newton's second law of motion, F equal to what? MU. Mass into acceleration, F equal to MU. So what are the applications of Newton's second law of motion? So catching a cricket ball, when a fielder is catching a cricket ball, he will take his hand backside, because momentum, a large force act in a small amount of time, then he may get hurt. So if he takes the ball back, if he pull his hand backside, time elapse increases, so he may not get hurt, right? So Newton's second law of motion, applications of Newton's second law of motion. One is catching a cricket ball. See, applied force, it depends upon force is directly proportional to force. Momentum is directly proportional to the applied force. When you apply more force, there will be a more momentum. Momentum is nothing but product of mass and velocity. Okay, so that is what you have to remember here. Change in momentum. Momentum is nothing but F equal to mass into velocity. If there is more mass, okay, then you require more force. That is the reason we are considering as directly proportional. If force is more, then its velocity is more, right? If mass is more, then force required to push the body is also more. So they both are directly proportional, right? F equal to mu. The second one is the case of high jumper. When an athletic, he will do high jumping, no? They'll keep a heap of sand in order to not to get hurt to his legs, because he has within a short span of time he will jump. Okay, large force will act in short interval of time. Large force acts upon short interval of time. That is nothing but momentum. The third one is use of seat belt. Nowadays all the vehicles, all the cars are having seat belts. Why? So if he is having a seat belt, that elastic is there, no, it takes time to hit the front side, because it is an elastic, so it takes time. So within a small span of time we may not get hurt. It takes time. That is the reason we may get less hurt, or else without any injury we can come out of that. So that's what we have Newton's second law of motion. What is the Newton's second law of motion? F equal to mv. Force is directly proportional to the product of mass and acceleration. F equal to mv. That is called as Newton's second law of motion. Now coming to Newton's third law of motion. Whenever a body exerts a force on another body, the second body exerts an equal and opposite force on the first body. Suppose we have a blackboard is one body, arm is another body. Whenever I exert a force on another body, the second body exerts on an equal and opposite force on the first body. Okay, so applying a force on second body is called action. And what is the reaction? The second body is also exerting the same and equal force on first body. Second body exerting a force on first body is called as reaction, right? So to every reaction there is an equal and opposite. For every action, to every action there is an equal and opposite reaction. For every action there is an equal and opposite reaction. That is our Newton's third law of motion, right? So what are the examples of Newton's third law of motion? For example, how do we walk? When we are walking, our foot applies a force on the ground. In turn, ground exerts some force on us. The second one, why the gun recoils? So gun to మనం coil చేసేటప్పుడు ఏమైతుంది, బుల్లెట్ ఫోర్స్ తో ముందుకు పోతుంది. అట్ ద సేమ్ టైం ఆ గన్ మన వెనక్కి వస్తుంటుంది, జస్ట్ ఇట్లా ఫార్వర్డ్కి వస్తుంటుంది. And then the flying of jet aeroplanes and rockets. The flying of jet aeroplanes and rockets are also principle of what? Newton's third law of motion. It follows the principle of Newton's third law of motion. And the case of boat and ship. Okay, boat తో మనం దాన్ని పుల్ చేస్తున్నప్పుడు వాటర్ పుల్ చేస్తే వాటర్ అట్ ద సేమ్ టైం బోట్ని ఫార్వర్డ్గా చేస్తుంటుంది. దీస్ ఆల్ ఆర్ ద some illustration examples of Newton's third law of motion. Okay, so far we have discussed about Newton's law, first law of motion, second law of motion and third law of motion. These three are the most important laws of motion. Okay children, thank you.